12.3, we're going to be talking about inscribed angles and circles. Okay, so the measure of an inscribed angle is half the measure of its intercepted arc. So if I have it in, the angle is inscribed, so it's touching the opposite side of the circle, it's going to be half of whatever the arc is. Okay, if I have two inscribed angles that intercept the exact same arc, the angles are going to be congruent. So angle A and angle B are going to be congruent. When a quadrilateral is inscribed in a circle, so that means it is inside, it's written inside the circle, the opposite angles are supplementary, okay? So BD add up to be 180 and AC add up to be 180. An angle that is described in a semicircle is always a right angle. So we're going to do some. Okay, so this angle should always be double what the inside is, or this one should always be half of what the arc is. So we're going to double it to get angle A. So angle A is going to be 48. Okay, this one we have to take half of 88 to get my inside one, so it's going to be 44. This one, we have to figure out what the arc actually is. Well, it's 360 degrees for the arc, so if I do 90 plus 96, I get 186. And if I subtract that from 360, I get my outer arc here. So 360 minus 186, this is 174, and then we need to take half of it to get that inside angle, that inscribed angle, so 87 degrees. Okay, so we have an angle here that's with that 56. So if I do 56 divided by 2, I can get A, which is 28. I'm going to change colors here. I have this angle here. So if I do 94 divided by 2, I can get B, which is 47. It looks like I have a triangle within this. So I can do 180 minus 28 minus that 47 and get this to be 105, and C is a vertical angle of that. So this will be 105. So you got to realize that there are triangles within it to find all of the angles. Okay, this one we said if they're across from each other, if I have a quadrilateral inside it, they're going to be supplementary. So if I do 180 minus 76, I get this to be 104. And then if I do 180 minus 98, I should get the one across from it, which would be 82. And now we got to figure out what my central angles are touching. So this A here would give me this entire thing. So if I double 82, I have 164, but part of my arc is already 34. So if I take away 34, I get B to be 130. Let's erase some of this color here. Okay, now we got to find our next one. So let's say we pick this one that's attached to 98. Okay, that one is going to give me this whole thing, which I can't find yet because I don't have either one of them. Well, I can find the total. Okay, so if I want to do total 98 times 2, that total arc is 196. Problem is I only want part of it. So now let's look at, that 76 and figure out what it's touching. So that 76 is this. So if I double it, I figure out how much I share between those two arcs, so 152. This one's already 34, so I'm going to subtract that 34 out of it to get my C, which is 118. Okay, first off we can find this arc. So if I double 80, I get 160. I can find the last missing arc. So if I do 140 plus 160, I get 300. So 360 minus 300, A is going to be 60. I can cut that in half to get this little angle here. So that's going to be 30, and then I have a triangle. So if I do 80 plus 30, subtract that 110 from 180, B is going to be 70. Looks like we have a quadrilateral in here. We also have multiple triangles. So first off, if I look at that 74, it looks like that arc here is touching that angle here. So if I cut it in half, I'm going to get 37 here. And this one's actually hard to see, but we have inscribed triangles in it. Anytime we have an inscribed triangle, so if I look at this blue one here, I have the diameter going all the way across, and it's a triangle that's inscribed, so this is going to be a right angle, so that's going to be 90, and then we have one on the opposite side too, so that's going to be 90. So to find those missing other angles, I do, since they're triangles, 90 plus 37, which gets me 127. Subtract that from 180, so this is going to be 53. My other one, I do 90 plus 40, which is 130, and subtract that from 180, and that gets me 50 for this if I was trying to find that. Okay, and then if that's 50, we need to figure out what angle this arc is touching, so I can figure it out. So it's touching these here, so I can double that 50 to get that C, which is then going to be 100. Okay, the last things that we're doing, so the measure of an angle formed by a tangent and a chord is half the measure of its intercepted arc. So angle C is going to be half of BDC. So this angle is going to be half of that entire arc that it's intercepting. Okay, this angle is going to be half of that entire arc that it's intercepting. Okay, so it should be half of it, so that means to go the opposite direction, we're going to have to double it. So 106 times 2, this is going to get me 212. Okay, if I was trying to find this one here, I'm going to cut it in half, so 224 divided by 2. So this little angle is going to be 112, and that's going to be a straight line. So if I wanted to jump in there, I would do, well, you got to be careful with this, but if I wanted to find the measurement of B, the whole circle is 360, so if I do that 360 minus 224, I should get what B is, which is 136, and then I can cut that in half to get my A. So 136 divided by 2 is going to be 68. You could have also seen that it was a straight line to get that 68, or doubled the 68 to get your B. Okay, so this central angle is 38. Remember, the central angles come from the center, so that means this arc is 38. So that means the whole thing should be 360. So if I do 146 plus 38, subtract that from 360, I should get, what I want left is 176. We have to cut that in half to get B. So this is going to be 88. And then A, if you look, is actually what we were doing previously. And so I have to cut 38 in half to get him, which is 19. Okay. A triangle is inscribed in a circle. The triangle divides the circle into arcs with the following measures: 46, 102, and 212. What are the measures of the angles? Well, if it's inscribed, that means we have to cut all of these arcs in half to get their inner angles. So the first one's 23 degrees. 102 divided by 2 is going to be 51 degrees, and then 212 divided by 2 is going to be 106 degrees. Okay, so a representation of what it would look like would be something like this, and then we got like what, 46, you got 102, and then 212.